Hello and welcome to your first Year 9 homework, which is on the topic of density. You need to access the questions which I've sent you for homework, and you can find them in your school email address's inbox to which they've been emailed. I've emailed them in the form of a OneNote page, and the OneNote page is called Year 9 Density Homework. Now if you want to open this, you can download OneNote for free. It's free to use on your computers, it's available for Windows and Mac, and it's a piece of Microsoft software. Alternatively, you can actually access the questions just by looking at the video here. I'm going to show you them all on the screen. So all you need to do is attempt 3 questions. The questions are quite difficult, so I want you not to spend longer than about 20 minutes on this. You've got more important things to do, like running around outside and watching TV. Question A is as follows. Are you ready to begin writing? Your mother gives you a kilogram of aluminium and a kilogram of lead. Both objects are solid rectangular blocks. Question 1, which is more massive on the surface of the Earth? 2, which is more massive on the surface of the Moon? 3, which is heavier on the surface of the Earth? And 4, which is heavier on the surface of the Moon? By the way, massiveness is a measurement of how much mass something has. Heaviness is a measurement of how much weight something has. Question B. A lucite cube, lucite is a type of translucent plastic, has a mass of 142.5 grams and a width of 4.9 centimeters. Determine its density in kilograms per cubic meter. Apologies, there's a mistake there. That should be m to the power 3. I don't think I'll give you any help with this. C is a difficult question. It's really a challenge question. If you're able to do this, I'll be very impressed. Remember, spend no longer than 20 minutes on this homework. So here it goes. It has been known for several thousand years that the Earth is spherical. Sometime in the 2nd century before the Common Era, meaning before 0 AD, the size of the Earth was determined, and our Earth, the radius of the Earth, was found to be 6,370 kilometers. By the 19th century, its mass was known. M-Earth, the mass of the Earth, turned out to be 5.97 times 10 to the power 24 kilograms, and there's another mistake there, apologies. And in the early 20th century, we deduced the structure of the Earth. It has 3 main layers. It's got a crust around the outside. There it is. Apologies for the messiness of this. It's got a mantle within that, and it has a core in the middle. The crust is the lightest and thinnest, and like the shell of an egg, contributes little to the overall mass. Therefore, my diagram is not to scale. The proportions are not correct. The mantle is a bit more dense, substantially thicker, and contains most of the Earth's mass. The core is the densest layer, but not the most massive, and is divided into a liquid outer core and a solid inner core. We've got data for the interior of the Earth in a table there. So in the first column, you're told which layer of the Earth we're talking about, whether the crust, the mantle, or parts of the core. You're also given the depth range of each of the layers, and that tells you exactly how deep the layers are, when they start and when they end, as you're going from the surface of the Earth towards the core. So the crust goes from 0 kilometers into the Earth to 20 kilometers into the Earth. The mantle goes from 20 kilometers into the Earth to 2,890. And if we add the outer core and the inner core together for simplicity, it goes from 2,890 kilometers into the Earth to 6,370. So far, so good. Now there are 5 questions for you to complete. Determine the average density of the entire Earth, thinking about its overall mass and its overall volume. You might need to recall the equation for the volume of a sphere. The volume of the sphere, if you can't remember, is equal to 4/3 times pi times the radius of the sphere cubed. Remember, the radius is the distance from the center of a sphere to the outside. Question 6 is determine the percentage of the Earth's mass located in the mantle. So what you need to do for that is to first work out the mass of the mantle, and then work that out as a percentage of the mass of the overall Earth. You're given the mass of the overall Earth up here, which simplifies things for you, but how are you going to work out the mass of the mantle? Now question 7, determine the average density of the core. I won't give you any help with that, but it's probably the most difficult question you're going to face in this homework. Any problems, come and see me. I'm usually in S8 after school. S8. Thank you.